Hi, this is Team 8. We have made an application that does sentiment analysis of social media web trends. We use semantic web technologies for this application basically to provide structure to the unstructured data. The social media that we are considering is basically YouTube, Twitter, and Flickr. All of these have different types of data. YouTube has videos, Flickr has images, and Twitter is just unstructured text. So we use semantic web technologies to provide structure over all of this data and then do a sentiment analysis. We use Alchemy API for sentiment analysis, and we use DBpedia to get rest of the data that we want to display on the presentation layer. So let's go ahead and start the server first. So as you can see, the user has two options here, get sentiment and show history. So when I click on get sentiment, a call is made to the backend. As you can see, we are getting data from YouTube, Twitter, Flickr, and then we have data from Alchemy. And then these are all the DBpedia queries for the entities and keywords that we extracted. Once this is done, we should be able to see the sentiment here. So right now, social media web trends are positive. We can get the details which basically show which entities and keywords are contributing to that social media trend. So you can see that there are so many entities that contribute to this, but at this point of time to the particular overall sentiment. If you want, we can see the details of any particular entity. So we have Batman. When we do see more, this basically is a keyword. So we are just getting Batman and movie here. LAPD. So this is all this data, description, thumbnail, references, RDF types, all of this is coming from DBpedia, and all of this is actually correct data. So if the user wants to see details of it, they can go ahead and open it, and all this data is coming from DBpedia. The entire backend is where the logic sits. So the backend was implemented using Spring, and we made REST services. So like you can see, these are the sample REST services. Let's do a code walkthrough now. So the entire code is divided into two structures, a backend and a front end. The backend contains all of the services related code that's written in Java. So when you come inside services, source, main, Java, sentiment generator, this is where all of the classes reside. All the helper classes are basically used to hit external APIs. So we have Alchemy helper, we have Flickr helper, we have Twitter helper, we have YouTube helper. So all of these make calls to external APIs, and they have corresponding beans. So you have YouTube beans, you have Flickr bean, you have Twitter beans. All of this are the representation of data that we want. So once we hit these three social media services, we collect the data, give it a structure, and then we use Alchemy helper to get sentiment and keywords and all of that. And then the generate RDF is where the entire RDF is created. So here you can see certain Apache Jena related code where we create RDF on the fly. So that was amongst the biggest challenges, to be able to create RDF on the fly for this project. And all of this RDF is cumulatively added to this file, wsa.rdf. So right now, as you can see, like it's a huge file, and as and when you keep on making calls, this file will keep on increasing. The way we did this in this manner is because we had experimented with the triple store, and we were getting a lot of challenges, especially related to performance. So we instead went ahead and stored everything in a single file. But basically all that data that we want to show on the front end is available on this file. So we execute Sparkle queries, and we get data from this file, and we show it on the front end. So that is also the entire workflow. To sum up the entire workflow for the backend, it's first we hit the three social media websites, we get the data, we hit Alchemy, we get further details about it, then we hit DBpedia to get the remaining details, and we generate this RDF. The front end code is pretty simple. It's built using AngularJS and Bootstrap. So the basic structure is like this. You have an app folder in which there are all these files. So all the views are here in partial. So you can see home.html, like we saw, get sentiment and show history button. That is how this is coming up. And each of the partial is related to a bunch of controllers where all the front end logic is written. And the factory has the logic for making HTTP service calls. So that is the entire front end as well. So it's a pretty simple app, like you can see. So to sum up, basically this app is pretty useful because we are able to do sentiment analysis of unstructured data from various sources, and the architecture is pretty modular. So if anyone wants to extend this, they can add new helpers for say Facebook or Instagram, and it is pretty easy to include that as well. So thank you.